MacMaths, let's do some maths today. Okay, jingle over. Today I'm going to look at, this is my third lesson in the vector series to go with the Pure AS mathematics. And guys, today I'm going to look at magnitude, direction and unit vectors, and those three things because they are what are described in exercise 11C in the Pearson AS Pure Mathematics book. Okay, so I've already, in my first lesson, I talked about magnitude and direction. So very briefly on that, I just want to just cover a few things for you. If you remember our first one, we in my first video I explained, this vector, and it turned out to be I plus 5j, didn't it, in the I and j form. So it was 1 along and 5 up. And we talked about the magnitude of that is the length of that line, the value, the length of that line. It was a force, or a speed. The speed it was going, or the force that you're pushing, would be the length of that line. And we said simply, we find that by Pythagoras, don't we? The length of the line, it's 1 along and 5 up, so we just use Pythagoras. The notation for magnitude, if we call this A, is you'll see these two lines either side, or they might even put them around the brackets. If you see that, that means they're asking you to find the magnitude of, and the magnitude of this would be the square root of 1 squared plus 5 squared, which is root 26, wasn't it, this one? So if you see these lines, it actually, from pure mathematics, it's the modulus. It means it only takes the positive value. That can only be a positive value along. Even if you had the vector minus I minus 5j. Okay, so that's 1 along that way and down 5. If this is still, a positive length, isn't it? Even though you're going back and down, and it's described as minus I minus 5j. And actually, if you find by Pythagoras this one, well, I is minus 1. So by Pythagoras, the magnitude of this vector here would be minus 1 squared plus the square root, of minus square root of minus 5 squared. So, talking rubbish there. So, any of you that minus 1 squared is 1 and 5 squared is 20, minus 5 squared is 25, so the square root of 1 plus 25 is square root of 26. So, that is the magnitude of this vector, same as the magnitude of that one, would be root 26. Okay? So that's all the magnitude is, so just get used to seeing these lines. If you see these lines, it means the length of the line, the value of the vector, the length of the vector, whatever. Also the direction, we talked about the direction. Of course, the way that I always do it is I always just think of it in terms of I and j. So I'll look at my I and j. This was I plus 5j. So it's, effectively I always draw my dotted lines in to create the right angled triangle. Okay, and it's 1 along and 5 up. Okay, and then just from basic trigonometry, I always find that angle there and opposite over adjacent. So this is the inverse tan to the minus 1 of 5. Okay, because 5 over 1 is 5. Opposite over adjacent for tan, and that tells you it's an angle of about 79 degrees. When we use this in mechanics, because that's, this is really sort of introducing you to what we're going to use in mechanics, you do have to quantify that 79 degrees. 79 degrees from where some reference point is needed. In mechanics, you'll see them describe it as 79 degrees from the horizontal. Okay, so that makes sense. That's horizontal. That's a 79 degrees turning, isn't it, from the horizontal. You may want to describe it yourself. They're not too precious about this at A level. You might want to take away all ambiguity and describe it as a bearing. In other words, turning back from north. So what would that be? That'd be 11 degrees, wouldn't it, to make 90? So, that, if it was a force, acted of root 26 newtons, it's acting as a bearing of 011 degrees, isn't it? 3 digits turning clockwise from north. Okay, so we could describe that as a bearing. Okay, so that's magnitude and direction. But I want to, before I move on to the unit vectors, I just want to pose you the question, what happens if we get it the other way? Okay, so what happens, for instance, if they give you a vector and they tell you that it has a magnitude of 8, okay, so it's, if it was a force, 8 newtons, if it was a speed, 8 meters per second, so it has a length of 8, and then they gave you the angle that it was acting at. Well, let's give it some reference point. Let's give it this north line, and let's say that this is, I don't know, 40 degrees there. Okay, so they tell you that a vector is 8 units long, and it's acting in the direction of 40 degrees to a north line or something. It gives you an angle somewhere. Okay, so that's the other way around. If I was doing this, I would always sort of, do my right angle triangle on it. Okay, so actually in my triangle I don't want that angle. I'd convert it to this angle here. Now this is our I to it, isn't it? And this is our J. So those are the two that we're going to find in a second. Okay, the I and the J of this vector. We could use this angle because you can see that the I is the same as that distance there, and the J is the same as this distance up here, and that's just the same right angle triangle sort of flipped over, so with the 40 degrees up there. So we could use that 40, in a different sort of version of what I'm doing, but I always like to find this one here. So once I've done that, I can just rub those out now, so it's not confusing you. How do we find the I and the J? So this is the I, isn't it? And this is the J. Well, this is, if you think about the I, what we're more used to, aren't we, is seeing this as the, along the x-axis, and this is the amount up the y-axis. So if we look at that, first of all, we know from basic trigonometry, now that we've got this angle here and we've got our right angle triangle, we know from basic trigonometry that the cos of 50 is equal to the adjacent over the hypotenuse. Okay, and the cos of 50 degrees, the adjacent is that x value that we want over the hypotenuse, which is 8. And if we times both sides of this equation by 8, to get rid of that divide by 8, we're left with x, and we get 8 cos 50 degrees. There we go. So this distance here, this x distance, is 8 cos 50. 8 cos 50. That's that distance. Now I could work that out. I could put 8 times cos 50 into my calculator, and I get a horrible decimal that I have to round off. But I can leave it like that because it's nice and exact. Now you probably spotted that y is going to be 8 sine 50, and you end up doing these very quick. The sine is always connected with the opposite, and the cos is always connected with the adjacent. So if we did the sine of 50, the same thing, opposite this time over hypotenuse, because that's the ratio, isn't it? So the sine of 50 is equal to our y value, that's our opposite value, over 8. And times both sides by 8, and we get 8 sine 50 is equal to y. So this is 8 sine 50. Okay, so if we wanted to write this now in the I and J form, we know that we can get to this 8 by saying 8 cos 50i, that's the amount, that's the distance along the x-axis, and 8 sine 50 J, and that's our I and J form. We've left it as exact values there, and we would use this, we're going to use this in mechanics. It's a really important skill because we're going to look at combinations of forces, and then we can just add up all of the I's and keep them exact, and add up all of the J's to find out what we call a resultant force. Okay, and this is just one force of 8 newtons acting in an angle of 50 degrees to the horizontal, if we want to look at it in context. Okay, so that's how we can split it out. We can work that out if we want and get a decimal, but it never looks as nice, I don't think. 8 times the cos of 50 is equal to 5.14 and 8 sine 50 is equal to 6.1 j. So that's it, you know, rounded off to 1 decimal place. Not as nice. And there we go. So if you have to do it the other way around, if you're given the magnitude and given an angle, adjust that angle so you get the 1 to the horizontal, and just use your little triangle and basic trigonometry to find your values. Try to, you know, leave them as exact values. Okay, and you are asked that in exercise 11C to exercise that skill. It's a bit, yeah, I don't really like the way that they've included vectors into the pure mathematics thing, because this is really mechanics and that's where it's actually used for. And I'm going to have another grumble now, because I'm going to cover the unit vectors, because that's also in 11C. So the unit vectors are in 11C, and I actually don't know why, because they just ask you in the exercise to work out the unit vector, which without telling you, you know, what for, what's the point of it, just work out the unit vector. So I'm going to finish with what the point of that is. But first of all, we're going to simply look at what a unit vector is. Well, a unit vector, first of all, that word unit, it refers to 1, you know, and it's just a vector that has a magnitude of 1. So let's have a look at a simple one. Let's have a look at the vector 3i plus 4j. You'll see this one a lot, and you may realise why. 3i plus 4j is a nice vector. There it is, okay, because what it is a vector that is 3 along and 4 up. Okay, so 3 along and 4 up, not that my diagram is very accurate. Okay, 3 along and 4 up, and you can see from this one that if we were to work out the magnitude by Pythagoras, well, let's put the i's and j's on there, if we were to work out the magnitude of this by Pythagoras, that the magnitude would be 5. It's the 3, 4, 5 triangle. Well, a unit vector is just that same direction, but 1 unit in that direction. In other words, a fifth of the way along this line. That's a unit vector, just one, you know, 1/5 of this. So this is not a unit vector because it has a magnitude of 5, but a fifth of this is a unit vector. So in other words, a fifth of 3i plus 4j is a unit vector, and that's it. So if you wanted to calculate the unit vector of 3i plus 4j, you work out its magnitude. Its magnitude is 5. You know, obviously it's a fifth, and that's it. If you wanted to, you can multiply this out. So we multiplied it out. I'll do that in my red pen. You get a fifth times 3, so 3/5 I plus 4/5 j. It's the same thing, okay? That's the unit vector. If you were to find the magnitude of this vector by Pythagoras, it would be 1. You know, that squared plus that squared, all square rooted. That squared, of course, is 9/25, plus that squared is 16/25, 4 squared and 5 squared. And the square root of all of that, 9/25 plus 16/25, of course, is 25/25. And the square root of 25/25 is the same as the square root of 1, isn't it? 25/25 is 1, square root of 1 is 1. Okay, so you can see that it works. If we take, that's a really obvious one, which is why I chose it. But if we take our old friend, the one that I started off this lesson with, I plus 5j, not so nice. So you have to apply just the same maths to it. Okay, there's my I plus 5j. Remember, 1 along and 5 up. 1 along and 5 up. 1i and 5j, there it is. If we use Pythagoras on that, this distance now is root 26. Not as nice as our 5, is it? So 1 unit up that is a 1 over root 26. If it was 10 units long, it would be a tenth. If it was 20 units long, it would be a 20th. If it's a root 26 long, it's a root 26th. I don't even know whether that's a word. Okay, so I plus 5j, there is the unit vector, well, you know, for I plus 5j. Okay, or if you multiply it out, 1 over root 26i plus 5 over root 26j. And again, you know, if you did Pythagoras on that, square top and bottom, square top and bottom, you'd end up with 26 over 26, the square root of, which of course is the square root of 1, which is 1. Okay, so those are unit vectors. It doesn't really say, it doesn't say this in the book, you know, it just asks you to find them. It doesn't really explain why. I'm just going to finish now this lesson with explaining why we need unit vectors. Because you're going to come across a question, you know, a bigger question, but part of it, say in mechanics, is talking about, you know, a car, and a car travels at 8 meters per second, the -1, you know, in the direction. Okay, now it gives you a direction in terms of I and j, say. So in the 3i plus 4j, let's use that one because it's easy. And it says find a vector. For the velocity. Okay, well, first of all, a velocity is a speed with direction. So we've got the speed and we've got the direction. This is not the velocity vector. This is only the direction, 3i plus, it's going in that direction. It's not the velocity vector because the magnitude of that, of course, is 5, isn't it? You know, 3 squared plus 4 squared square root is 5. It's a 3, 4, 5 triangle. So it's the right direction, but it's not the right velocity. So we need to combine these two to get a velocity vector that has that same direction, but that magnitude. And an easy way of doing it is just to take the unit vector of this. Okay, so if we take our 3i plus 4j, if we do the maths like we did before and work out the magnitude, okay, so if we the magnitude of 3i plus 4j, you can see that I'm using these parallel lines either side of it to say to indicate that I'm finding the distance that you would travel if you did 3i plus 4j, which is 5. So that's the magnitude. Okay, so therefore the unit vector is a fifth of 3i plus 4j. So once we've found the unit vector, we know that this is just one unit, isn't it? It's just one unit in the direction of 3i plus 4j. It's actually 3/5 I and 4/5 j. That's what it is, okay? And that gives us a magnitude of 1. And if we times that by 8, of course, okay, it's now got a magnitude of 8. So all of this times 8, and a fifth times 8 is simply 8/5. So we just put it on the top, don't we? Of 3i plus 4j. And there we go. Meters per second. That's what unit vectors are really used for. They're used to, you know, in a case like this, it's like saying it's like that GCSE problem, isn't it? 5 pens cost, you know, 4 quid. How much do 8 pens cost? Well, you find the cost of 1 pen and then use that information to find the cost of 8 pens. And that's what unit vectors are for. They're used as an intermediate stage to find something relevant to the question that we're then going to go on and use this, you know, in the maths. And it doesn't really do that. It just asks you to find the unit vector and doesn't tell you why. And if you learn something and it doesn't really attach to anything else, then you quickly forget it. So, but we're going to cover this again in the mechanics when we start the mechanics next week. Okay. Again, you could multiply this out if you wanted to. You don't have to have this fraction outside. It's just a neat way of doing it. But if you multiply it out, 8 threes are 24, so you could have it as 24 fifths I plus 4 eighths are 32, 32 fifths J. You could have it written like that if it was a speed, for instance, or you could factorise out and take out, 8 fifths from both of those if you want. Okay, so that's unit vectors, and I'll go very quickly. I'll do a lesson 3A and just go through a couple from that exercise, because now that I've done this, it should be fairly straightforward. Okay,